Exponential growth occurs when a quantity increases by the same factor over intervals of time. This equation you see right here is your exponential growth function equation. So because we're growing, what you see here is the R stands for the rate of growth. You're going to add that onto 1 because it's increasing, you add. And the T stands for time. A is still the initial amount where it starts. We're just going to go ahead and do it and see what happens. The one thing I'll remind you of is you have to have the rate of growth in a decimal form. So if you want to write just a couple steps out here, these are going to be really small. The first thing you have to do is make your percent into a decimal. And then you're going to add that to 1. So when you're doing exponential growth, make sure your percent is added as a decimal, add it to 1. And then you should be able to write your function or your equation. So we're going to use that model that's at the top here. So it's the inaugural attendance of an annual music festival is 150,000 people. Whoa. The attendance Y increases by 8%. So that 8%, that's your rate each year. Write an exponential growth function that represents the attendance after T years. So step 1, change that percentage into a decimal. And in case you forgot how to do that, 2 options. So we're changing our percent to a decimal. If you want to make some notes out for yourself, if you don't remember how to do this, fastest way is to just move your decimal 2 places to the right. Take this, move it 2. To the right, to the left, 2 spaces to the left. Or you can divide by 100, you'll get the same thing. So we have 8%. If you take your decimal for 8% and you move it 2 places to the left, or if you divide by 100, that's the same thing. 1, 2, now it's here. That would be the same thing as 0.08. And if you don't believe me, you can do 8 divided by 100. You should get the same thing. So that's your rate, the R. So now you take R and you're going to add it onto 1. So Y equals, guys, what's my initial amount? Where's it start?
150,000.
That's a lot of people. Yep, we start at 150,000, so that still goes in the front. And then in parentheses, you're going to put 1 plus, because we're growing, you add. We want our rate to be greater than 1. 1 plus 0.08, which is how much is increasing. The reason we're adding it to 1 is because we're going to keep it the same, but then also multiply it by 8%. Raise that to T. Now we're going to simplify this in a second and make it 1.08, but for now, since we are out of space, we'll leave it like that. How many people will attend in the 5th year? And then we'll round to the nearest 1,000th. So let's go ahead and simplify this. Let's add what's in the parentheses together. So the final equation would be this, 1.08 to the T. So every year increases 8%, which is why we multiply by 1.08. If you just multiply by 0.08, you would get a number that's smaller than 150,000, and that would be decreasing. That's not what it's doing. So now we have T equals 5, because after the 5th year, substitute that into your equation. Yep, Jackson?
Do you only add 1 if it's below 1? Like if you're resetting?
We add 1 if it's growth. And the reason we're adding 1 is because it's like you're saying, I am doing 108%. It's 108% every time, every year. So it's increasing, but you can't just multiply by 8% because then it would get smaller. So take your calculator. You can type this in all at once, as long as you type it in correctly. 150,000 times 1.08 to the 5th power. Please make sure you got a calculator.
Did you do that,
Should work out to type it in all at once. Your calculator should know to do the exponents first. If you do it correctly in your calculator, and I do need you to do this on your own so you actually know how to do it later. Be 220 and 399. 220,399 people. If that's what you get in your calculator after you plug this in, then it has been plugged in correctly. Because we're going to round this in a second, I'm not even going to worry about the decimal. So the nearest 1,000.
220,400 people.
Okay, nearest 1,000 is what we're rounding to, and so the 1,000 place is here, the 0. Number to the right of it is 4 below, so we let it go. So it's going to be 220,000 people. Round it to the 1,000. So don't worry about the hundreds. So percent as a decimal, add it on to 1 if it's growth. So you got to pay attention to what it's asking you. And then plug in. Okay, questions on this one? Or does anybody need help with their calculator? Okay, then we're going to move faster on the next one. Website has 500,000 members in 2010. The number Y of members increases by 15% each year. So it's growth because it's increasing. Write the function. You have to take 15% and change it into a decimal. What is 15% as a decimal if you move the decimal place to the left? 0.15. So that'd be 15 hundredths. So when you write your equation, it starts at 500,000. And then I'm just looking at this template right above 1 plus R. So this is R is 0.15. 1 plus 0.15 to the T, the time. Would you go ahead and simplify that? Add what's in the parentheses together. So that would be 1.15. So 115%. Okay, it says in how many members will there be in 2016? How many years have passed? 6, so T equals 6. Substitute that in. 500,000 times 1.15 to the 6th power. If you plug it all in your calculator at once, you should get the correct answer. I will write the answer up on the board just so you can confirm that you've done it correctly. But I do want you to do it in your calculator yourself so you can actually do it by yourself later. And if you don't have a scientific or graphing calculator of your own, usually you can just Google scientific calculator and you'll find one for free. Graphing calculators, not so much. But scientific will work. Yeah, it's a lot. But read what it says. To the 10,000. The 10,000 place is this 5. The number, so it goes ones, tens, hundreds, thousands, 10,000s, 100,000s. So the 5 is the 10,000s place because it's 50,000. Number after it is 6, so you do round up. 5 or above, give it a shove. 4 below, let it go. So you're going to round up. And so final answer would be about, is this people? Oh yeah, members. 1,160,000 members. So it told us to round to the 10,000, which is why I'm doing that. If it doesn't say to round, then just look at your thing. Are you talking about members, people, money? If you're talking about people, you obviously can't have decimal places. If you're talking about money, you can. So that's writing equations. Now we're going to compare growth and decay. And we'll do one more with decay. So whenever you're ready, you can flip it over. Decay is when we have a quantity decreasing by the same factor over time. So increase, growth, decrease, decay. And same thing for my steps, but just one small thing is different, and it's pretty important that you pay attention and decide before you start writing an equation, is it growth or decay? Because you still start out by making your percent to a decimal.
You still make it a 1 or
We're going to have a 1 there, but we're going to, subtract. Because it's decay, you subtract, so that way the number is less than 1 in the parentheses. That way it does end up decreasing. Subtract from 1. So notice how it's different. A is still there, but you have 1 minus r to the t. We'll do that in a second. First, we're just going to look at some stuff and decide growth or decay. So look at that little note there. It's got a star next to it. Notice that for exponential growth, the value inside the parentheses ends up being greater than 1. If you don't believe me, flip it over to the front. Both things we had, 1.08 and 1.15 are greater than 1 because r has been added to 1. For exponential decay, it will be less than 1 because r is subtracted. Determine whether each table represents growth or decay. Okay, number 3. As x increases, is my y growing or decaying? Decaying, decreasing, so decay. Because if you want to make a note, it decreases. Great. Next one, number 4. As x increases, what does y do? Does it grow or decay? Grow. So this is exponential growth. Because it increases as x increases. And then the last one, what's it do? Grow or decay? It does decay because it decreases. It's dividing by 4.
So say it's a word problem for the decay, is it just like the exact, pretty much the exact same?
Pretty much the exact same thing, but we're going to subtract. So now we're looking at equations. If the number inside the parentheses is greater than 1, it's growth. If it's less than 1, it's decay. So number 6, you got 1.07. Is that growth or decay? Growth. Because it's increasing by 7%. And it does ask us to go ahead and identify the percent rate of change. You had 0.07 added onto 1. What is that as a percent? You move your decimal to the right 2 places, and you get that it is, 7% is your rate. Number 7. Our number is less than 1 inside the parentheses. Growth or decay? Decay. Okay, think about what would you have to have subtracted away from 1 to get 0.98?
2.
Not 2. Close?
1.
It's not 2. You're close, but I want you to be specific. Joe, is it?
Is it 1?
No. If you 0.02. Thank you. Yeah, I'm being picky. 0.02 is what you got. If you subtract it away from 1, you get 0.98. So move that decimal to the right, and you get that is 2%. Decrease every time. And the last one, numbers greater than 1, growth or decay? Growth. What was added? 0.02, which we know, we just talked about, that's 2%. The last one is a word problem, except read it and pay attention and decide before you make an equation, is it growth or decay? Okay, you're looking for keywords. The value of a car is $21,500. It loses, unfortunate, 12% of its value every year. And when it drives off the lot, it loses a lot of value. So that's why you should not buy new cars. You should buy used ones. Get really nice used cars instead. Life lesson. Okay. Write a function. So this is exponential growth or decay? Growth or decay?
That's decay.
Decay, losing value. Unfortunate. Happens to every car. Unless you got a really old one that is good, right? So we are going to take 12% and make it into a decimal. Move that decimal place 2 to the left. What is this as a decimal? 0.12, which would be 12 hundredths. So your function then is going to be y equals, starts at 21,500, and you are subtracting 0.12 from 1 because it's decay. You're subtracting. I got to have you remember that because otherwise it's going to increase. We want it after 6 years, so simplify your equation here so it doesn't have that subtraction anymore. What would 1 minus 0.12? Yeah. 0.88. So every year it's only worth 88% of its previous value. You are substituting 6 years in for t. Go ahead and figure out what that would be. You're talking about money. It's okay to have 2 decimal places, right? Because we were talking about cents. Plug it in, plug it in. If you get an answer that is larger than the value started at, then something happened. The value should be decreasing. You do want to have 2 decimal places. Your answer is on the board. When you plug it in your calculator, check and make sure you get the same thing. You want to leave it like this with 2 decimal places. You weren't told to round it, first off, but also money, you should have 2 places in this sense. Neat. Can you please explain? Yeah, 2 questions, I think, or maybe just 1. Yeah, what is the difference between exponential growth and decay? And how do I write an exponential growth and decay function? Explain with complete sentences. The difference between exponential growth and decay is what? Or just explain.